So the building blocks or the fundamentals of statistics are raw data, variables, constants, observations, and data sets. So let's go through some of this important terminology. So let's start with the raw data. So raw data is the numbers, the categories, the labels that you've collected but you've not yet processed. So in our research design videos, we talked about surveys, we talked about observational studies where you write down what you observe. All of this, we're collecting raw data. So we need a way to take our raw data, the information we collect, and turn it into something meaningful. Now, there's a couple steps in this. So we have the raw data. There's the summarizing that raw data. So then we're better understanding the sample that we have collected. And then there's that extrapolation to the greater population to say, okay, well, what we're finding in the sample, is that true with the greater group? So let's start first with this raw data. These are the building blocks of statistics, right? So we collect information about someone's height or someone's weight, the color of their eyes, their GPA. Is that representative of everyone else? When we do a survey and we find that someone is extremely satisfied, is that indicative of how everyone else feels? So examples of raw data, and if we're looking at our raw data, can we identify what that data is? So when we say, well, what is your gender, right? So the raw data would be male, female, if they don't want to disclose, if they don't want to identify themselves, that is all raw data. How many hours did you sleep last night? 7, 15. That number is the raw data, right? We ask you about your favorite number, your age, your weight. We ask you about your favorite TV show. If the answer is Game of Thrones, right? That's raw data. If your answer is Fraggle Rock, then that's the raw data. So for each of these, whether we're taking it in terms of collecting the information from a survey, or whether we are collecting this information through observation or in our experimental process, this is that raw data. So then the next building block is a variable. So variables are characteristics that can differ from one individual to the next. Now, we're going to take that raw data and we would classify it into a variable, right? So if we had a question about eye color, the variable is eye color. The raw data would be blue eyes, brown eyes, green eyes. And so we would have different possible responses for a particular variable. If we're looking at the variable of GPA, raw data might be 3.5, might be 4.0. So raw data is grouped together into a variable. Our variables can be quantitative or qualitative. So quantitative, we talked about in previous videos, is a number. Qualitative is going to involve text, right? So if we are asking about color, blue, green, right? Qualitative. If we are asking if the variable is height, and then we're looking at 5'3", 6 feet, those are numbers, so quantitative. We can also take our variables and identify whether they are nominal, ordinal, interval, or ratio. And we talked about that in previous videos. So remember, nominal is where we have categories. Ordinal is where we have ranking. And with our interval, the distances between the numbers matter. So we talk about things like temperature. And then we have ratio where the difference matters, but also 0 means the absence of information. So that would be like height and weight, where if you have no weight or you have no height, you don't exist. So we take our raw data, we group it into our variables. Okay. And I gotta get all the way over here somehow. My mouse is not going far enough. There we go. Constants. A constant is a characteristic or a value that does not change. So variables vary, they change. They can be different for each person, and constants don't change across the individuals. So we want to recognize the difference between a constant, which is true for everyone, same number for everyone, and a variable. When we do things like a line of best fit, linear regression, forecasting, we'll have a formula for a relationship between two different items. So, for example, maybe there's a relationship between calorie intake and weight. And maybe it is the more calories you consume, the more weight you have. Okay? So, in that case, there is the change, right? So we have a variable, which is weight, and we have the variable, which is caloric intake. And both of those are different for different people. But there might be a constant that helps translate that relationship between, in terms of looking at how much one impacts another's in terms of the relationship. So we'll get into those constants as we start to build models. Then we have observations or observational units. So this is going to be your single individual or participant in your study. If you are doing a survey, each respondent who fills out your survey is going to be an observational unit. So when we talk about sample size, we're talking about the number of observational units. Now, it doesn't have to be people responding to your survey. It can instead be the number of flowers that you analyze. So each flower is going to be an observational unit, or if we're focusing on petals, we could look at each separate petal. So how are you separating out what each participant is or what each unit is within your sample that you are analyzing? When we combine those observational units and the variables about them, then we get a data set. So our data set, and we look at looking at a survey, for example, we have 30 people who respond to our survey. Our survey has 20 questions. Those 20 questions are each a variable. And so if we think about the spreadsheet filled out, every row is an observational unit. Each column is their response to those different questions, different variables. We have created there a data set. So let's look at an example. Suppose that a national survey of 620 randomly selected adults, each person is asked how important religion is to them, very, fairly, not very, and whether the person favors or opposes stricter regulations of what can be broadcast on network television. So when we look at this example, how many variables are measured in this survey? So one variable is how important religion is. I need to update this to say they. My apologies that is not gender neutral. And whether the person favors or opposes stricter regulations. So we have two variables here. We have religion and whether they favor or oppose stricter regulations. Now, if we look at these variables, right, we can talk about whether they are quantitative or qualitative. And in this case, we have the first one is how important religion is. That's going to be ordinal. That's going to have ranking to it. And the second is whether they favor or oppose. If that's going to be simply yes or no, for or against, just two in terms of that dichotomous variable. Then we have two categories, our nominal data. In nominal data is qualitative. Ordinal data, as we have seen in previous videos and we'll talk about further, is kind of straddles the line between qualitative and quantitative. And so in our future analysis, we will actually treat a lot of that rating scale as quantitative in our analysis, but it can also be seen as quantitative in terms of categories because we don't really know how far apart people's opinions are between very, fairly, not very. So it kind of straddles the two. And what's the sample size for this survey? The sample size is 620. So we have 620 observational units and two variables for each of those observational units.